Welcome back at Johnny's desk. Today let's make a PCB in easyEDA, the free software by JLC PCB. I don't get sponsored by them, I just like the software and service. I will show you how to get started with the program, how to set up your first project to either have it manufactured in China or to solder it on perf board with the help of a circuit board design. easyEDA is one of the easiest EDAs that you can get for free. I assure you that you can make your own PCB and manufacture it after this video. Let's start with opening the program, so we get to the home screen. Here you can choose what to do next. On the left side panel you can find all of your projects and the ones shared with you by others. If you just started, your project list should be empty. Now we create a new schematic diagram at the top left corner. Save it and a new folder appears in your project list. This folder holds up all of your important documents, one schematic and one or more PCB files. We can now place all of our components by either choosing from the EE-lib on the left side panel or by searching for them in the library. You should find almost any component you search for because easyEDA has a really big library and components created by other users can be used too. For today let's just use standard through-hole components like the axial 0.3 resistor, the radial capacitors or the pin headers. You always have to choose the right package so that your parts actually fit your PCB design. Otherwise it can happen that some components could not be populated and your whole PCB cannot be used. In some projects it might be necessary to jump between schematic and PCB more often to make sure all the components are in the right package. The program will check for errors all the time and sometimes asks us to check something. I suggest you to use shortcuts like R to rotate and W for wire. X and Y are for mirroring components. Of course we need an example project for today. Let's have a look at one of my modular synthesizer modules. This is a voltage controlled low frequency oscillator and this is how it sounds like. So it doesn't actually make sounds, but can modulate other modules. Here it modulates the pitch of one oscillator. This is a full schematic with all the components and connections. Keep in mind that you place your connections to the outside world as well. Now that we have the complete schematic of our project, we can convert it into a PCB in the top toolbar. As you can see, we now have a mess of components and red lines. Red lines are the thin lines that are connecting the components. They show you what to connect. This means it is now our job to place all the components the right way, so that all the red nets are as short as possible. You have to imagine a little bit how the traces will look like before you place them. The next step is to connect all the red lines with traces. This is a critical step because you have to consider many things like trace width, clearance and length. Red traces are on the top side, blue traces are on the bottom. You can switch between sides with B and T. Place wires, the connections between top and bottom, with V. In the beginning we turn off red nets of the ground net because we place a ground plane afterwards. Here we have a lot to think of. Some of these things are checked by the DRC, the design rule check. You should always have the right maximum or minimum values of your PCB manufacturer put in here. Although there's an auto router, you shouldn't use it and place the traces yourself instead. At least for your understanding and for your learning curve. Nets that carry high currents get bigger traces and nets that carry high voltage need more clearance between other nets or components. When all these nets are connected, there's one thing left. The ground plane. For that we select copper area and draw a rectangle outside of our PCB. Within this area a ground plane will be placed. You can set some values like clearance and clearance to border. If you would like to solder your project on Perfboard, you can do a PCB design too, but just don't print it. Just use 50mm traces and keep in mind that you might need some more room with that method. Don't forget to trace ground as well, because you won't have a ground plane if you solder by hand. Now it's time to order the PCB. Just click on Fabrication, one-click order, and your Gerber files get uploaded to JLC's website. Just fill in your preferences and order it. Easy. The last thing to do is to test the PCB. I've populated all the components and connected it to my synthesizer. This was it for today. I hope you come back next time, because we will have a look at how to order SMD assembly PCBs from JLC. Don't forget to subscribe to Johnny's Desk and leave a comment below. For those who kept watching, I have made a little song to summarize what we learned today. Bye, until next time.
Are you lost in the network? Are you looking for components and an easy way to make your own circuit board? easyEDA is the answer. Use it to integrate yourself into the system. If you want some circuit board, you need easyEDA. Draw your circuit nice and clean, there is no better way. All components are installed, connections are complete. When you find yourself in trouble, easyEDA is all you need. Keep in mind the clearance and make the traces big enough.